Okay, so here's our first lesson in our unit on electricity. And so we're talking about electrostatics and the basics of static electricity. And so we're going to begin by just stating exactly that electrostatics is the study of static electricity. Okay. When we say static electricity, this word static means something, and that's basically that the charge on an object is stationary or is motionless. So static means it stays put. So the charge does not move, it just builds up on the object. As soon as we get charge that's moving around, that is what we call current electricity, and of course the electrons will move, or the charges will move in circuits. But this is a little bit different. This is electrostatic, so the charge stays put and builds up on an object. We can create a static charge when we rub two objects together, and this is called charging by friction. Okay, so when two objects are rubbed together, what ends up happening is that the electrons from one will move to the other. So the electrons from one object will move to the other. And one of the really good examples of this is if you take a balloon and you rub it against your hair, electrons will move from one object to the other, and both will become charged. So when an object has a lot of electrons, it takes on a negative charge, and that's because electrons are charged negatively. When an object gives away its electrons, it takes on a positive charge. And so these are the basics of static electricity. Now let's talk about some of the laws that are involved in electricity and specifically static electricity. First of all, we know that two objects that are charged the same, that we call like charges, these like charges will repel. So in the diagram here, two negative rods will repel each other, and two positive rods will repel each other. Rule number 2 states that two objects that are charged oppositely will attract each other. So a positive rod in this diagram would be attracted to a negative rod in this diagram. The third rule or law of electrostatics states that neutral objects will attract charge objects. And so an example of this is the balloon that, of course, we've rubbed against our hair has built up an electric charge. And when we bring that charged balloon close to the wall is charged negative, the wall is neutral, and will attract the charged balloon. The last rule is that two neutral objects do not attract or repel each other. They simply coexist. So when two objects are neutral, there's no attraction that takes place. If we flip the page, we're going to talk for a couple minutes about how we determine if an object is charged. An electroscope is a device that allows us to test whether an object is charged or not. So the main parts of an electroscope are a metal sphere or ball, a metal rod or shaft, and two metal leaves. And so you can see a diagram of an electroscope here where we have the metal sphere, the metal rod, and the two metal leaves. The ball, the rod, and the leaves are all conductors of electricity. It's because they're all made of metal. And conductors allow negative charges, known as electrons, to move through them very easily. When the metal leaves move apart, you know that the object that you're bringing close is charged. So let's go through two examples that will happen when we bring a charged object close to the electroscope. So here in the first example is a rod that's charged negatively. This rod is brought close to the sphere on top. Now, of course, all throughout this electroscope, there are positive charges and there are negative charges. But because the electroscope is neutral to begin with, the number of electric charges, positive and negative, balance each other out. However, we've now brought a negative rod close to this metal sphere at the top. And so what happens is that the electrons in the sphere are going to be repelled by the negative rod. So these electrons here are going to want to move away, and of course what they'll do is they'll move down the rod, and they'll end up in the leaves. So the electrons rush down the electroscope to the leaves, which means that the sphere in this local area, the sphere is now, this kind of area here, is a little bit more neutral. Some of the electrons have left, which means that the positives up here will balance with the negatives up here. But the trade-off is that now in the leaves, we have many electrons. So the leaves are now charged negative, and the leaves, because they can move, will want to get away from each other, and so they will separate. And that's how we know if the object is charged. When we bring it close, the leaves will separate. So let's look at the example when we bring a positive rod close to the electroscope. Again, we have negative electrons all the way throughout the electroscope. But because the electroscope is neutral, the leaves do not repel. So in this case, what happens is that the rod is charged positive and it's brought close to the sphere. Now we know that when we're talking about electricity, the protons, the positively charged objects, cannot move. Only the electrons can move. So in this case, what happens is that the electrons in the sphere, the rod, and the leaves, all these electrons, are attracted to this positive metal rod. Attracted to the positive rod. Which means that these electrons, or some of the electrons, will travel up through this and will end up up here in the metal rod. Now, unfortunately, what happens, or fortunately what happens, so let's write that out. The electrons rush up the electroscope to balance out this big positive charge at the top. And what ends up happening now is that when we examine these leaves, both leaves are charged positive, and once again, the leaves will separate. So the leaves are now charged positive because the electrons have left, or some electrons have left, and the leaves will separate. And this is kind of how an electroscope works.